Hello, teacher. I am Fatih Hancı, you know. I hope you and your family is fine. I wish we could do homework in the classroom, but we have to do it at our home. Today I will talking about wind turbines. My topic is wind turbine. Okay, let's start. Okay, wind turbine. What is the wind turbines? A wind turbine generally consists of tower, blades, rotor, gearbox, generator, electrical electronic elements. The kinetic energy of the wind is converted into mechanical energy in the rotor. The rotational movement of the rotor shaft is accelerated and transferred to the generator in the body. The electrical energy obtained from the generator is stored by means of batteries or delivered directly to the receivers. Two important aerodynamic forces must be well known to understand how wind turbines work. These are drag and lift forces. The drag force is a force occurring on the body in the flow direction. For example, while the maximum drag force that can occur on a plate is 19 degrees perpendicular to the body, the minimum drag force occurs when the airflow is parallel to the surface of the object. Lifting force is a force that occurs perpendicular to the flow direction. Since this force caused the planes to take off from the ground, it was called lifting force. The best example of drag force is parachute. Thanks to this force, the speed of the parachute is cut. Special objects made to minimize the effects of drag force or called streamlined objects. Examples of these objects are ellipse, fish, zeppelin. The lifting force acting on a flat plate is seen when the airflow reaches the plate surface at an angle of zero. Low pressure areas occur with increasing flow intensity at small angles occurring according to the airflow direction. These regions are also called downstream. Therefore, there is a relationship between airflow rate and pressure. In other words, the pressure drops as the airflow accelerates and the pressure increases as the airflow slows. This event is called the Bernoulli effect. The lifting force also creates suction or pull on the body. Classification. We need the classification wind turbines. Out of the wind turbines in use vary in size and type. They are generally classified according to the axis of rotation. Wind turbines are divided into two classes as horizontal axis wind turbines and vertical axis wind turbines according to axis of rotation. Horizontal axis wind turbines. In this type of turbines, the axis of rotation is parallel to the wind direction. Their wings make a right angle to the wind direction. Commercial turbines are generally horizontal axis. The rotor is placed on a rotary table to get the wind in the best way. Most horizontal axis turbines are designed to take the wind from the front. Turbines that take the wind from behind have no common use. The good part of the turbines that take the wind from the front is that they are not affected by the wind shedding formed by the tower. The downside is that the rudder system is built so that the turbine constantly faces the wind. Example of horizontal axis turbines are propeller-type wind turbines. The blades of these types of turbines can be either one piece or two or more pieces. The most used type today is the three-winged ones. These turbines are used to generate electricity. In the past, multi-blade turbines have been used to grind grain, pump water, and cut down trees. Vertical axis wind turbines, a kind of different wind turbines. The turbine shaft is vertical and perpendicular to the direction of wind arrow. There are variants such as Savonius tape, Deruyev tape. It's mostly produced for experimental purposes. It has very little commercial use. The advantages of these turbines can be listed as follows. Since the generator and gearbox are placed on the ground, it is not necessary to place the turbine on the tower. So, there is no tower expense. There is no need to turn the turbine to the wind direction. So, the rudder system. Maintenance and repair of parts other than the turbine shaft is easy. It's easier to transplant since the power obtained is at the gradient level. There is wind turbine. There is wind turbine was patented in 1931 by French aviation engineer Georges-Jean Marie Derieux. It's a vertical axis wind turbine used to generate electricity from the energy carried by the wind. The turbine consists of several curved aerofoil blades mounted on a vertical shaft. Savonius wind turbine. This shape is really different. I'm interested in. Savonius wind turbines fold into the vertical axis. Wind turbines class used to transfer wind energy as a torch to a rotating shaft. Two or three airfoils are in combination of a bucket-like cross-section. The most common is the situation where there are two scopes and it has an appearance resembling an shape. Wind power calculation. This is mathematical calculation. There are a lot of mathematical calculations. Okay. There are two kind of wind turbine which is very interest. First, floating wind turbine. The floating wind turbine is the sea wind turbine mounted in a floating structure as deep as possible by fixing the seabed of the turbine tower with the foundation. Terrestrial features that disrupt wind follow detailed wind from its activity on the water surface can be stronger and more stable in the sea. The produced electricity is sent ashore with underwater cables. The rate of energy production competes with more options at sea. The cost of the first large floating turbines, wind turbines on the beach fixed to the bottom. Wind blowing is more stable and continuous than on land. The location of the offshore wind fields, if the used turbines are made more than 19 km offshore of the sea. They are found in fishing, ship transitions, and increase in coastal settlement and include visual point. Second kind of wind turbine I interest because shape is very interesting and beautiful. I like its name's flying wind turbine. The flying wind turbine is a wind turbine standing in the air without a tower. Flying wind turbines can operate at low or high altitudes. These are a large part of flying wind energy systems and are addressed as high altitude wind power. When the generator is in ground, the glider it is attached to does not need to carry it or has a temporary fastener. While the generator is in the air, a temporary fastener or upper glider can be used to transmit energy to the ground or teleport to the receivers using a microwave or laser. Flying turbine systems have the advantage of almost constant wind direction without the need for ignition switches or deviation drives and towers. hoop gliders and helicopters that can when there is not enough light. This subject, my topic is finished here. Thank you for watching me, teacher, and I hope you will give me high points. Thank you for watching. Thank you.